Imagine you're an archaeologist and you've just found the site of the century, and say that site is Göbekli Tepe in Turkey. You've discovered that hunter-gatherers were building enclosures with these massive pillars up to 3 times your height 11,000 years ago, and the pillars have got these intriguing symbols on them. You're dying to find out what these images and symbols mean, right? I'm Madam Archaeologist, your go-to informant on everything archaeology, and in this episode, I'll explore one possible interpretation of Pillar 43 at Göbekli Tepe that draws mainly on archaeoastronomy. I'm not here to prove or disprove anything, I'm here to explore a possibility. When we're dealing with prehistoric material, we often don't have one sole interpretation to explain our material. We have many different possibilities, and what I'm looking at here is one less discussed possible interpretation of Pillar 43. Göbekli Tepe is an archaeological site in southeastern Turkey known for its stone enclosures featuring T-shaped pillars that boast a number of intriguing symbols, many of them animals. Dubbed the world's first temple, excavations at the site began in the 1990s, but the story of its discovery actually starts in the 60s, when the universities of Chicago and Istanbul performed a surface survey of the area and wrote the surface evidence off as an uninteresting medieval cemetery. Then in the 90s, the German archaeologist Klaus Schmidt found out about the site and decided to check it out for himself. He realized that there was more to the mound than meets the eye, and it was much, much older. Until 2014, he led the excavations at Göbekli Tepe, and what he found would change history, or more accurately, prehistory, forever. Klaus Schmidt discovered that the site was characterized by a series of astounding megalithic enclosures. He interpreted Göbekli Tepe as a site of religious importance based on the evidence he found, and didn't find, during his excavations. While he was director, no obvious dwellings were discovered to suggest that Göbekli Tepe had been a settlement. Only monumental architecture that, with no apparent domestic function, probably held a religious or cultic significance. However, more recent excavations have found domestic buildings, some of which bordered an activity area that contained hearths and evidence for bead production. Still, there is nothing to suggest that the 4 currently considered oldest enclosures at the site served a domestic purpose, so a religious or cultic significance for them is more likely. What makes the site so incredible is that the projectile points found there and the fact that all the animal bones were of wild animals tell us that the enclosures were built by hunter-gatherers. Radiocarbon dates support this. Klaus Schmidt labeled the enclosures he'd excavated with letters according to their order of discovery, and the first 4 enclosures, A, B, C, and D, come from the oldest level at the site, Layer 3, which has been radiocarbon dated to the 10th millennium BC. These dates are consistent with the period archaeologists have termed the pre-pottery Neolithic A, when hunter-gatherers were starting to transition towards settled lifestyles and relying more on agriculture. Other excavated structures date later, to the pre-pottery Neolithic B, and it is noteworthy that they are less elaborate than the older enclosures. However, most of the site has yet to be excavated, and Klaus Schmidt thought it possible that parts may go back to Paleolithic times. Limited radiocarbon dates suggest that the construction of enclosures A to D were not exactly contemporaneous, but this needs to be further clarified. One of Göbekli Tepe's most distinctive features is its T-shaped pillars. If we look at enclosures A to D, these pillars can be found embedded into each enclosure's stone walls, and then 2 huge pillars up to 5.5 meters tall can be found in the center of each of these enclosures. The central pillars are taller than those that are embedded into the walls. And these are not even the only enclosures at Göbekli Tepe. Klaus Schmidt mapped the site through a geomagnetic survey, including ground-penetrating radar, and he found that other circular enclosures, perhaps as many as 20 or more, await excavation. Göbekli Tepe's importance cannot be underestimated. It was a game-changer, precisely because of how advanced it seemed for hunter-gatherers. It was previously thought by many people that our ancestors couldn't build monumental architecture until after they'd become settled and had built up a food surplus. Göbekli Tepe predates reliance on agriculture as the main form of subsistence, and so it completely changes our understanding of the transition from hunting and gathering to farming. But it is also one of the most mysterious sites, far from being fully understood. What do the symbols on its pillars mean? What were the beliefs of the people who built the site? It's prehistoric, so we have no written sources to guide us in our interpretations. Klaus Schmidt himself drew some interpretations based on comparisons with other Neolithic sites in Turkey, but, as any good archaeologist studying prehistory would do, he noted that we are far from answering all the questions at the site, and that more research is needed to better understand it. He was also of the opinion that archaeologists alone won't be able to fully understand the nature of the site and the meaning of the T-shaped pillars, and that collaboration between different specialists are needed. I agree. As archaeologists, we are obviously trained in interpreting the past, but we could also benefit from incorporating the expertise of other researchers from various disciplines. And here, I want to focus on one possible interpretation that's been put forward in recent years for Pillar 43, also known as the Vulture Stone, found in Enclosure D. Pillar 43 is embedded into the inner surface of the enclosure's round wall, and it is rich in symbols and imagery. Many animals can be found on it. On the front, we see this bird of prey with its wings spread out. Above one of its wings, we see a circle. To the right of this bird, we see two more birds, and next to the upper bird is a snake-like creature. Beneath, there is clearly a scorpion, and then further down is a canine figure and the head and neck of a bird. It's got a long neck, so it could be a goose, duck, or swan, but these animals are partially obscured. At the top, we see three of what have been termed handbags due to their shape, and beside the handle of each, there are three more animals. At the very bottom, next to the long-necked bird, is a headless man. It is a very peculiar set of images and symbols. But what do they mean? The interpretation that I'm exploring today proposes an astronomical association with the markings on Pillar 43 and links the pillar to a proposed catastrophe called the Younger Dryas impact event, which I'll elaborate on soon. It is essentially an attempt at decoding the symbols on this pillar. This interpretation is discussed in a couple of papers. The first, Decoding Göbekli Tepe with Archaeoastronomy, What Does the Fox Say?, was published in 2017 in the journal Mediterranean Archaeology and Archaeometry, and the other paper, Representations of Calendars in Time at Göbekli Tepe and Karahan Tepe Support an Astronomical Interpretation of Their Symbolism, published in the journal Time and Mind in 2024, elaborates on the original interpretation and also includes a response to the criticisms archaeologists made in reaction to the 2017 paper. This intriguing astronomical interpretation that will blow your mind, I hope, was put forward by the scientists Martin Sweatman and Demetrius Tsikritsis. Martin Sweatman in particular has dedicated a lot of time to studying the pillars at Göbekli Tepe from an archaeoastronomical point of view, and with his background in physics and geochemistry, he can certainly bring very useful knowledge to the table, and it would be great to see a collaboration between him and archaeologists. In these particular papers, Pillar 43 is seen as a memorial to the Younger Dryas impact event, and the animals are seen as representing constellations. Before getting into the details, what's the Younger Dryas? The Younger Dryas was an episode of abrupt cooling that started around 12,800 years ago and lasted for about 1,200 years. Here is the Younger Dryas cooling episode represented visually. You can see the sudden dip here. The planet was starting to warm up, and then suddenly, in just a matter of decades, the temperature in the northern hemisphere plummeted and the Earth went back to glacial conditions. Not a fun time to have been alive. The end of the Younger Dryas marks the beginning of our current epoch, an interglacial known as the Holocene, when the planet resumed its warming trend. A big question is, what caused the onset of the Younger Dryas? One explanation has been termed the Younger Dryas impact hypothesis, which, in very simple terms, posits that the cooling episode was triggered by a cosmic impact. I'll get into the details very soon. The study to first publish evidence in favor of the Younger Dryas impact hypothesis in a peer-reviewed journal was this one: Evidence for an extraterrestrial impact 12,900 years ago that contributed to the megafaunal extinctions and the Younger Dryas cooling. Published in 2007 by Richard Firestone and colleagues. A side note, the date has now been recalibrated to roughly 12,800 years ago, but this is not a big deal. Here in this paper, the authors analyzed material from sites across North America within a thin sedimentary layer they call the Younger Dryas boundary, abbreviated YDB, which often sits directly beneath a so-called black mat at many sites. At the YDB, researchers have found proxy evidence for an extraterrestrial impact event and associated biomass burning, some of which includes high concentrations of iridium, magnetic microspherules, carbon spherules, nanodiamonds, charcoal, and this is not an exhaustive list by any means, but just some of the proxies that may be used to identify a cosmic impact event and related biomass burning. Iridium is an element that is very rare in the Earth's crust, but is more common in meteorites, asteroids, and comets, so finding high concentrations of iridium is suggestive of a cosmic impact event. An example of a known impact event is found at the Cretaceous-Paleogene boundary, associated with the asteroid impact that caused the dinosaur extinction 66 million years ago, and in that layer, high concentrations of iridium were found as well. Volcanic eruptions can also deposit iridium, but these are typically accompanied by other geochemical signals that are absent at the YDB, so cosmic impact is the most likely explanation for this particular geochemical marker. It's also worth noting that high concentrations of platinum, which has also been seen as evidence for cosmic impacts, were found not only at the YDB at some sites, but also in the JISP-2 ice core from Greenland at the onset of the Younger Dryas. Magnetic microspherules have also been found at the Cretaceous-Paleogene boundary and can be associated with impact events, but they can form through other processes too. Studying them scientifically will, however, usually allow a researcher to identify their origin because the formation processes are different. There is an abundance of evidence for a cosmic source of the microspherules found at the YDB at many sites. Carbon spherules can be associated with cosmic impacts as well when they contain nanodiamonds, which Firestone and colleagues identified. Nanodiamonds, which are diamond particles that are so small they are measured in nanometers, themselves are another line of evidence. Natural, terrestrially formed nanodiamonds are extremely rare, but nanodiamonds are associated with astronomical objects. The fact that they have been found at the YDB at many sites, and in the absence of evidence for volcanic activity, adds weight to the Younger Dryas impact hypothesis. They have also been found at the Cretaceous-Paleogene boundary and at a couple of known impact craters. Now, sure, many of these lines of evidence, these proxies, on their own might not be enough to confirm a cosmic impact event, as critics of the hypothesis say. However, its proponents say that the proxies are not to be looked at individually, but as a whole, and together they are strongly indicative of a cosmic impact. This review even claims, I quote, that these specific signals have only ever been found together in the context of a cosmic impact, end quote. It's also worth noting that the YDB contains evidence of biomass burning as well, because it is expected that the extreme thermal radiation emitted from the cosmic impact would ignite extensive fires. When it comes to evidence for burning, charcoal is a no-brainer, but this in itself absolutely cannot indicate a cosmic impact because it is also associated with natural wildfires. However, at the YDB, charcoal has been found in association with other lines of evidence, and since these occur at the YDB alongside cosmic impact proxies at various locations, the most parsimonious explanation for their occurrence at the YDB would be that the extreme thermal radiation resulting from the cosmic impact ignited the fires. Now, what exactly was the nature of this cosmic impact? The original evidence led Firestone and colleagues to propose that one or more large, low-density extraterrestrial objects exploded over northern North America, partially destabilizing the Laurentide ice sheet and triggering Younger Dryas cooling. Later stating that the evidence is more consistent with an impactor that was carbon-rich, nickel-iron poor, and therefore most likely a comet, end quote. They suggested two possibilities regarding the nature of the event, but with the disclaimer that more work is needed to confirm this. 1. The Earth encountered fragmented comet debris that produced various airbursts. And 2. One or more extraterrestrial objects about 2 kilometers in diameter collided with the Laurentide ice sheet, the dynamics of which could have prevented the formation of a large crater. Airbursts in this context are when extraterrestrial objects explode in the Earth's atmosphere, and these may or may not leave craters since fragments are capable of causing ground impacts. However, since this paper was published, the hypothesis has been refined with growing evidence, as is expected in science, and the most probable scenario at the moment is impacts in the form of multiple airbursts. As stated here, the YDB hypothesis posits multiple airbursts or impacts across at least 4 continents. These are proposed to have resulted from one of a series of short-period active comets known to break up frequently and to shed dozens to thousands of fragments that are 10 to 1,000 meters in diameter, each capable of producing catastrophic airbursts or impacts, end quote. It's likely that one of those airbursts took place somewhere that could have been viewed from Göbekli Tepe and the greater region, since cosmic impact proxy evidence has been found nearby at the YDB at Tel Abu Huraira in Syria. Originally, scientists had some trouble replicating the evidence found by Firestone and colleagues, leading to a premature rejection of the Younger Dryas impact hypothesis, but these were later found to be mainly due to methodological or sampling flaws, and researchers started independently replicating the evidence in abundance. To date, cosmic impact evidence has been found in the Younger Dryas boundary at over 50 sites across various continents, including North, Central, and South America, Europe, Asia, and Africa. I'm not going to go through all the studies that have been published on the topic and evaluate all the research that has taken place since 2007. That would make this a 5-hour-long episode, but to sum everything up in 2 sentences, in that sediment layer called the Younger Dryas boundary, proxy evidence for an impact event, probably in the form of airbursts, have been found at many sites around the globe. The evidence from the original 2007 paper has been replicated, and impact proxies have been found to be a widespread phenomenon, meaning that at this moment, the Younger Dryas impact hypothesis cannot be rejected. Let's now get to the part where everything comes together. Interpretation of Pillar 43. The paper mainly puts forward an astronomical interpretation for the symbols found on the pillar and proposes a link between this pillar and the Younger Dryas impact event. The authors see it as a possible memorial to that event. But how did they make this potential correlation? If we interpret the disk here as representing the sun and the animals as representing constellations or asterisms, then we find something very interesting. Take a look at these figures from the papers. The bird of prey next to the possible sun disk looks very similar to the so-called teapot asterism, or bow of Sagittarius. Underneath Sagittarius is Scorpius, and what do we see underneath this bird on Pillar 43? A scorpion, the symbol of Scorpius. To the right of the bird of prey, we see another bird with a snake to its right, and if we look at the image of the sky, we can then suggest that the creators of this pillar associated this bird with Ophiuchus, a constellation also associated with serpents, symbolized by a snake. The bird's position relative to Scorpius, the authors note, isn't 100% accurate, but they also know that whoever created the markings on Pillar 43 had to work with the shape and size of the pillar. That is reasonable. Let's see what other associations can be made. The constellations beneath Scorpius are Libra and Lupus. Lupus is clearly represented by the likely canine here, which means that Libra must be represented by the duck, goose, or swan. Even though the ancient Greeks associated scales with Libra, Libra has also been associated with swans. It may not be in the perfect position, but again, the creators had to work with the shape of the pillar, and it is in the approximate position, and we're only seeing the head and neck. The body is obscured. The one animal the authors couldn't interpret was the other bird next to the bird of prey. This doesn't affect the final interpretation though, as it could represent an asterism we don't recognize today, or it could have had another meaning. It doesn't change the fact that we see this crazy pattern with the other animals represented on the pillar. Next, the authors, using these carvings and finding out at what point in time the sun was in this position on one of the solstices or equinoxes in southern Turkey using an astronomy software called Stellarium, dated Pillar 43 to 10,950 BC, give or take 250 years, giving us a range between 10,700 and 11,200 BC. This coincides with the Younger Dryas impact event. What are the chances that all of this, the date and the pattern seen in the images on the pillar aligning nicely with constellations and asterisms, would be just a mere coincidence? The authors did actually perform a statistical test to find out if the latter of the two, that pattern they identified correlating the animals with constellations, was just a coincidence, and I'll get to the results soon. If the astronomical interpretation is correct, it could mean that our Greek constellations have a very ancient origin, long before civilizations wrote about them. And this is not the first time that a Paleolithic origin for some constellations has been proposed. I don't see the fact that the authors used Greek constellations to study the animal images at Göbekli Tepe, which is clearly much older, as a flaw in their methodology. Finding this pattern suggests, in fact, that the symbols used to represent these constellations are much older than originally thought. So rather than say that the correlation is based on assumption, as some critics have pointed out, I would say the contrary, that it suggests that the symbols representing these constellations at Göbekli Tepe are likely ancestral to the Greek ones. Some of these symbols persisted, such as the scorpion, while others changed, like the symbol associated with Libra. I don't know exactly who built Göbekli Tepe, but there's a very good chance that they were what we genetically call Anatolian hunter-gatherers, since they're the ones who lived in the region at that time and were indigenous to that land. The Anatolian hunter-gatherers were the ancestors of the first Neolithic farmers in Anatolia. Some of these Anatolian farmers then migrated westward into Europe, settling early on in Greece. This could be one route in which the knowledge about these constellations and their symbols made their way there, and then that knowledge was preserved for millennia. This is just one possibility for the transmission of knowledge and symbols, but it's one that we should consider. As for the so-called handbags on the upper part of the pillar, one possible interpretation of them here could be that they represent sunsets due to the fact that semicircles are being shown. The date estimated by the authors, approximately 10,950 BC, corresponds to the summer solstice. So the authors suggest that these animal symbols here reference specific constellations at the winter solstice and the equinoxes around the summer solstice of approximately 10,950 BC. They get the following constellations: Virgo at the spring equinox, represented here by a downward crawling quadruped, maybe a frog; Gemini at the winter solstice, represented by what might be a charging ibex; and Pisces at the autumn equinox, represented by the bending bird. You can see the correlations here visually at sunset on the predicted solstices and equinoxes. There are similarities between the shape of the constellations and the animals supposedly symbolizing them. And these were also included in the statistical test I previously mentioned. Remember, the authors performed this test to find out if the pattern they identified correlating animals with constellations and asterisms was just a mere coincidence. And they found out that the chance of that is less than 1 in 5 million. The statistical test was later redone to reduce the potential of bias as much as possible, and in this recent article on Martin Sweatman's blog, the statistic was changed to 1 in 1.4 million, which is still very significant. From a statistical perspective, there's a higher chance of this interpretation being right than wrong. Now, what makes the monument a possible memorial to the Younger Dryas impact event is its date. that date stamp from the main panel. It may have recorded what the sky looked like that night. The authors also see it as a possible memorial because of the image of the headless man found at the bottom right, which may represent death since he's clearly headless. But this new date of 10,950 BC, give or take 250 years, predates the earliest radiocarbon date for Enclosure D, where the pillar was found. And this has been pointed out by some archaeologists as one of their criticisms of the interpretation. However, they also point out in their critique that many of the pillars were originally placed somewhere else and then moved to these enclosures. This point really isn't in their favor though, because by pointing this out, they have completely left the door open to the possibility that Pillar 43 is older than the 10th millennium BC. Also, remember that most of the enclosures at the site haven't been excavated yet, so it's completely possible and actually very likely that some of them were constructed before Enclosure D. We'll only know for sure when we excavate and scientifically date the other enclosures, but until then, this remains a possibility. If Pillar 43 is older and was placed in Enclosure D at a later date, then it very well could be a memorial to the Younger Dryas impact event. People didn't want to forget that moment. Martin Sweatman makes a good point in the more recent paper about how it's not uncommon for cultic and religious buildings to reference events that had taken place a long time ago. This is very true, just look at churches. Many were built long after Jesus' life, and yet they reference crucial moments in his life and scenes in the Bible abundantly. This is because they are stories that are important to Christians. If this pillar is indeed a memorial to the Younger Dryas impact event, then that event must have been important enough to the builders of Göbekli Tepe that they wanted to preserve the knowledge of it. If true, I can imagine that the pillar would have been accompanied by oral stories that are, unfortunately, lost to us today. Also, if we accept that the pillar is recording the sky on a specific date in a symbolic manner, why pick that date? Something significant must have happened for people to want to record it in stone. An impact event could be one such event. Just something to consider. All of this is very interesting, but it's not the type of interpretation you'll find in archaeology textbooks right now. Some of you may still be wondering, is this interpretation of Pillar 43 really possible? Can it actually be a memorial to the Younger Dryas impact event? So long as the Younger Dryas impact hypothesis has not been rejected, then the answer is yes, the interpretation remains possible. And as we saw, the Younger Dryas impact hypothesis has not been rejected. In fact, there's lots of evidence in favor of it. So yes, Pillar 43's interpretation as a memorial to the Younger Dryas impact event can be seen as a possible interpretation. I'm not saying accept it as the interpretation. As I said, I'm not here to prove or disprove anything, I'm just exploring a possibility. So long as the Younger Dryas impact hypothesis has evidence in favor of it, so long as it hasn't been rejected, this possible interpretation stands. When we're dealing with prehistoric material, we don't usually have one sole interpretation to explain the phenomenon. We often have various possible interpretations. Venus figurines or prehistoric rock art are classic examples. I don't see why we should treat Göbekli Tepe any differently in this regard. The association between the animals and constellations is, to me, beyond a mere coincidence, and this is supported by a statistical test. Now, statistical reality is not the only reality, but it is one reality, and so we should consider the interpretation that the creators of Pillar 43 and Göbekli Tepe more generally were recording what they saw in the sky as one possible interpretation for the images and symbols we see on the pillar. You don't have to agree with any of the interpretations explored here, of course, and the work presented here doesn't mean that there can't be other interpretations of Göbekli Tepe's pillars or that multiple interpretations can't be correct. Mainstream archaeology links Göbekli Tepe to a skull cult, but this doesn't really explain the specific meanings of the various symbols on the pillars. I also don't see why these different interpretations can't be compatible. The fact that Martin Sweatman has been called a pseudoscientist by some people for proposing his interpretation absolutely baffles me. It's unprofessional. Just because you disagree with someone doesn't make them a pseudoscientist. We're dealing with prehistory where, as we all know, many different interpretations can be possible, and this interpretation is being discussed and debated within academic circles. There's nothing pseudoscientific about it. Archaeological interpretations can always fall in and out of favor with growing evidence. It doesn't make our previous ideas about the past pseudoscientific. It just shows how our ideas are based on the evidence of the moment and that they can adapt to new evidence. I agree with the late Klaus Schmidt that we need to bring people with different expertise to gain a better understanding of the site. I really want to find out if an astronomical interpretation is compatible with all the other pillars within the enclosures, and I think the best thing that could happen is that archaeologists finally collaborate with Martin Sweatman and other scientists, because their combined expertise could allow for some really fascinating insights to emerge on what the images and symbols on Göbekli Tepe's pillars could mean. That's it for this episode. Feel free to let me know your thoughts in the comments and if there are any other interpretations of the pillars that intrigue you. Subscribe for more cool content, very go-to information on everything archaeology, Madam Archaeologist.